Hello students, today I am going to discuss inventory models with probabilistic demand. The models discussed in my previous videos are only artificial since in practical situations demand is hardly known precisely. In most situations, demand is probabilistic since only probability distribution of future demand rather than the exact value of demand itself is known. The probability distribution of future demand is usually determined from the data collected from past experience. In such situations, we choose policies that minimize the expected cost rather than the actual cost. Expected costs are obtained by multiplying the actual cost for a particular situation with the probability of occurrence of that situation and the either summing or integrating accordingly as the probability distribution is discrete or continuous. On the basis of demand and on the basis of stock levels, whether it is discrete or instantaneous, we have four type of models. The first model is having instantaneous demand, setup cost zero, stock levels discrete, and lead time zero. The second model is same except that the stock levels are continuous. The third model is having continuous demand, setup cost zero, stock levels discrete, and lead time zero. And similarly, the fourth model is with the stock levels in which stock levels are continuous. Now we will discuss these models one by one. The first model is having instantaneous demand, setup cost zero, stock levels discrete, and lead time zero. This model deals with the inventory situation of items that require one-time purchase only. Uh, the items such as cut flowers, cosmetics, seasonal items such as calendars, diaries, and spare parts fall under this category. In this model, the item is ordered at the beginning of the period to meet the demand during that period, the demand being instantaneous as well as discrete in nature. At the end of the period, there are two types of cost involved: overstocking cost and understocking cost. They represent opportunity losses incurred when the number of unit stocks is not exactly equal to the number of units actually demanded. Now, here we will discuss two type of situations in which discrete demand rate is less than equal to discrete stock level, and the second situation is in which discrete demand rate is greater than discrete stock level. These two situations we will discuss graphically. Here capital R represent the discrete demand rate with probability PR, and IM represent the discrete stock level for time interval T. Now the first figure is corresponding to the situations when discrete demand rate, that is capital R, is less than equal to discrete stock level for time interval T, that is IM. Here R is less than equal to IM. And the second situation corresponds to when the discrete demand rate, that is capital R, is greater than in discrete stock level for time interval T. Here capital R is greater than IM. Uh, the overstocking cost and the understocking cost is given by this formula. Overstocking cost is given by sum of C plus CH minus capital V. What is C? C is unit cost price, CH is unit carrying cost, and capital V is salvage value. And the understocking cost is given by this formula, that is capital S minus C minus CH by 2 plus CS. What is capital S? That is unit selling price. Capital C is again unit cost price. CH is unit carrying cost plus CS. What is CS? CS is unit shortage cost. Now, The optimum order quantity is determined when the value of cumulative probability distribution exceeds the ratio this, and it is computing by this formula. Now, to clearly understand this model, let us consider one example. Here, a trader stocks a particular seasonal product at the beginning of the season and cannot reorder. The item costs him rupees 25. That is, unit cost price is given by unit cost price capital C is unit cost price capital C is rupees 25, and he sells it at rupees 50 each. That means unit selling price is given by 50 rupees. For any item that cannot be met on demand, the trader has estimated a goodwill cost of rupees 15. That means the unit shortage cost is given as rupees 15. And next, any item unsold will have a salvage value of rupees 10. That means salvage value capital V is given as rupees 10. And further, holding cost during the period is estimated to be 10% of the price. That means holding cost CH is given as 10% of price, that is 10% of 25. If we further calculate it, this will become as 25 into 10 by 100, that is rupees 2.50. Now, with the help of these values, we can calculate overstocking cost and understocking cost. Overstocking cost C1 is given by the formula C plus CH minus V. What is capital C? Capital C is the unit cost price, that is 25. CH is unit carrying cost, that is rupees 2.5, and salvage value is minus 10. After calculating, we get it as rupees 7.50. And the this is overstocking cost. Understocking cost is given by the formula. Understocking cost is given by, say, C2 by the formula capital S minus capital C minus CH by 2 plus CS. Now, what is capital S? Capital S is unit selling price, which is rupees 50. Capital C is unit cost price, which is rupees 25. CH is unit carrying cost, which is rupees 2.5 by 2 plus CS. CS is unit shortage cost, that is rupees 15. After calculating this, we get rupees 38.75. This is understocking cost. Now, cumulative probability of demand is given as cumulative probability of demand unit stocked units stocked. We have given data as 2, 3, 4, 5, 6, and probability of demand is given as probability of demand PR is given as probability of demand corresponding to unit 2 is 0.35, corresponding to unit 3 0.25, corresponding to unit 4 0.20. These are as 0.35, 0.30. Oh, sorry, corresponding to unit 3, I think it is 0.25. That is 0.25. This is 0.25. This is 0.20. This is 0.15. This is 0.05. Now cumulative probability of demand, cumulative probability of demand is given as, this is 0.35. Add this 0.35 plus 0.25, this becomes 0.60. 0.60 plus zero point 0.2, this becomes 0.80. Then 0.80 plus 0.15, this becomes 0.95. Then 0.95 plus 0.05 becomes 1.00. This is cumulative probability demand. Now we will check it as, now C2 upon C1 plus C2 is given as, C2 is basically 38.75 as we calculated above, and C1 is 17.5 plus 38.75. After calculating this, we will get as 0.69. Now 0.69 ranges here. 0.69 lies between zero point 0.6 to zero point 0.8. Therefore, the value of Im, therefore, the value of the value of discrete stock level Im must lie between 3 and 4, and hence optimal order quantity is, optimum order quantity is equal to 4 units. This is the example related to model first. This is discussion of first model having instantaneous demand, setup cost 0, stock levels discrete, and lead time 0. In the next video, we will discuss about second model, in which we will discuss about the model when the stock levels are also continuous. Till then, thank you so much.